we get to combinations. 2.5 is part 1 of combinations. 2.6 is part 2 of combinations. So what's combination? A combination is a selection from a group of objects in which order is not important. Order is not important. Remember, with permutations, order mattered. We said the way you can remember that is permutation, position matters. But when it comes to combinations, the order doesn't matter. So an example of this would be if you're dealing cards. I don't know if you play cards or not, but let's say you're playing some game of cards and you're going to get dealt 5 cards. It doesn't matter which order you receive the cards in, whether you get the ace first and the king last, or the king first and the ace last. It really doesn't make a difference once you pick up the cards and look at what you got. And also picking lottery numbers. For my best understanding, I don't play the lottery, but my best understanding is you just pick a bunch of numbers and then the numbers are announced that were picked. You don't have to say, first of all I'm picking 7 and then I'm picking 12. No, you just pick the number 7, the number 12, number 3, the number 18 in any order you want. Order doesn't matter. Okay, so I'm going to give an example here. I'm already kind of regretting it because it's a lot of writing, but what the heck. So we're going to pick 3 things, A, B, C, out of 4. And the first way we're going to do it, we're going to say that order matters. In other words, this is a permutation, right? So we're picking 3 of the 4 things. A, B, C, I guess, is just an example, out of 4, A, B, C, D. And the order matters. So for example, A, B, C is different than A, C, B, right? Those are different. But let's do them in an order here that I can kind of do it systematically. So we can start with A and go B, C, or we can start with A, B, D. We could go A, C, B. We could go A, C, D. You could have A, D, B, and you could have A, D, C. Those are all the ones that start with A. Now, if you started with B, you could have B, A, C, you could have B, A, D, B, C, A, B, C, D, B, D, A, and B, D, C. Those are all the ones that start with B. That's B, D, C there. Next, starting with C, you could have CAB, you could have CAD, CBA, wow, it's bad, that's CBA. You could have CBD, you could have CDA, and you could have CDB. And finally, if you started with D, you could have DAB, you could have DAC, you could have DBA, you could have DBC, there's DCA, and there's DCB, and that's all of them. Oh my gosh, so how many is that? That's 6, 12, 18, 24, and that's exactly what you would expect because this is a permutation. And remember the formula for permutation? Basically what we're doing here is we've got 4 items, 4 distinct items, and we're picking 3 of them. And order matters. And remember the formula was n factorial over n minus r factorial. So n is the 4, it's how many distinct objects there are. And on the bottom you'd have 4 minus r is how many you're actually ordering. In this case it's 3. So you get 4 factorial over 1 factorial. 1 factorial is just 1. 4 factorial is 4 times 3 times 2 times 1, which is 24. And that's exactly how many we have here is 24. Great. Now we're going to do it again, but we're going to do it with combinations. And you're probably going, oh gosh, we have so much to write again. You actually don't have very much to write at all. Because if you think of it, if order doesn't matter, then you have ABC. That covers ACB, BCA, BAC, CBAC. They're all the same. So you got ABC when you leave out the D. You've got ABD when you leave out the C. You've got ACD when you leave out the B. And you've got BCD when you leave out the A, and that's it. If you compare these ones to all the ones we have over here, you'll see that all these ones over here are just one of these ones recombined. So we started with 24 over here, and somehow we ended up with 4 over here. So what did we do to the 24 to get the 4? Well, it looks like what we might have done is we might have done 24 divided by 6. Where would that 6 come from? Well, if you think about it, this ABC, let's just look at ABC. We've got ABC, BAC, CAB, got CBA, you've got BCA, and you've got ACB. Here's the 6 here. And these 6 here actually only end up with this one here. How come? Because there's different ways you can arrange the ABC. How many ways can you arrange ABC? To arrange 3 items, you can arrange them in 3 factorial ways. And that's why you have so many more here, is because you can rearrange these ones to get these extra ones. So in order to go from 24 to this answer, what you need to do is to divide by 3 factorial, because that's the number of ways the number of extra ones you have here because of your arrangements, which are distinct when you're talking about permutations. Confusing, right? All right, so basically what we're doing here is we're doing for, not P3, we're doing for C3, and what that's the same as is for P3, right? The same as the permutation, except we divided by 6. And what we've now learned, I mean, I guess I could put that 6, but what we actually see now is that what we divided by was 3 factorial. And what we also saw is that's the way this 3 factorial, I'll actually write it here. 3 factorial is the number of ways to rearrange 3 items or 3 elements. Alright, if that makes sense, that's great. I really love it. If it doesn't, I suppose this is all you need to know. Here's the formula. So the number of combinations of n different objects taken r at a time is equal to, well, first of all, there's 3 ways you can write it. Remember we had like NPR? Well, you can write the same sort of thing with combinations, NCR, but you can also write it like this, C bracket n comma r, but you can also write it like this, in a bracket, n r, like that. These all mean the same thing. It all means a combination of n different objects taken r at a time. And what the actual formula is n factorial over n minus r factorial. Hey, wait a minute, that's exactly the same as the permutation formula, but we also put a r factorial in here. And again, the reason we have that r factorial is because that's the number of ways of rearranging r number of elements. And we need to take that into account because when we rearrange them, it's actually just the same thing. Order doesn't matter. What else? R has to be less than or equal to n. You can't rearrange 7 objects and take 10 at a time. It doesn't make sense. And the way we say this, like when you're talking about combinations, what you say is n choose r. So for example, up here where it was 4C3, that's 4 choose 3. Okay, that took a long time. Let's see if we can zip through some questions here. So a group of 5 students is to be selected from a class of 35 students. How many different groups can be selected? So if you're just making groups of 5, order doesn't matter. Whether I pick Carl before Beth or Beth before Carl doesn't matter when I make a group of 5. So what I'm doing here is I'm starting with 35 students and I'm choosing 5. 35 choose 5. Well, the formula is n factorial, in this case 35 factorial, over 35 minus 5 factorial, n minus r factorial, right? But we also need to put an r factorial. It doesn't matter if you write it out here or out front. I'll put it out here. Okay, that's what will give you the answer here. So you end up with 35 factorial over 30 factorial 5 factorial. And you know, you could do that, or by the way, you also have a button on your calculator. I'm not going to show you. It's the same as permutations though. I showed you how to use the permutation button. Same thing with the combination button. So you could just go straight from here and put it in your calculator, and what you're going to get is the answer 324,632. Lisa, Gwen, and Al are students in this class. How many of the possible groups include all 3 of these students? Okay, so we're going to still have a group of 5. It's going to be 5 people. But one of them has to be Lisa, one of them has to be Gwen, one of them has to be Al, and then we've got 2 others. Order doesn't matter though. It doesn't matter if we pick Lisa first, Gwen, Al, whatever. Alright, the way to do this one, I guess, is to first of all just think of those 3 kids, Lisa, Gwen, and Al. We have to pick them. If you want, you could even say this. We have 3 kids, here they are, Lisa, Gwen, and Al, and we have to choose 3 kids. You can think of it that way. And, so it's multiplied, and we also need to get 2 more. But how many do we have left? We don't have 35 students left, right? These were 3 of those kids. So now how many kids are there besides Lisa, Gwen, and Al? There's 35 minus 3, which is 32 kids left. And how many of those do we need to choose? Well, remember we want a group of 5. We already have these 3 for sure, so we need 2 more. And that'll give us the answer. What's 3 choose 3? Can you think of what that would equal? If you can't, throw it in the formula, and I think you'll get it. You'd have 3 factorial over 3 minus 3 factorial times 3 factorial. So that's 3 factorial over 0 factorial times 3 factorial. What's 0 factorial equal? Remember this? It equals 1. So you're just left with 3 factorial over 3 factorial, and 3 factorial over 3 factorial equals 1. This makes sense. If you have 3 things and you need to choose 3 of them and order doesn't matter, then obviously you're just going to take all 3 of them, right? A lot of people, when they do this question, wouldn't even concern themselves with this first bit because it actually doesn't really impact the question. But I think it's nice to show just so you get a sense of exactly how the question works. Okay, so really what we're left with is the second part. So that means we have 32 factorial over 32 minus 2 factorial times 2 factorial. And again, I'm not going to work all that out, but if you do it, actually we could do this one pretty fast. This is equal to 30 factorial, so it'd be 32 times 31 times 30 factorial, which would cancel at the bottom, and 2 factorial is the same as just 2 times 1 or 2. Divide that, you get 16 times 31, and that equals 496. Sometimes it's satisfying not to use a calculator. Lots of questions to do with cards and combinations, because when you deal cards, as I said before, order doesn't matter. So we have a standard deck of cards, 13 cards in 4 different suits. We went through this before. How many different 5-card hands can be formed with only red cards? Alright, so let's think of black cards and red cards. How many black cards are there? There's 26 of them. How many red cards are there? 26 of them. How many black cards do you want to choose in order to have a hand with only red cards? 0. You don't want to choose any of them. How many cards do you want to choose so you have a 5-card hand with only red cards? You want to choose 5 of them. So we need to do this and this. This will be another multiplying question. Again, a lot of people don't do this first step, but I think again it kind of helps you understand the question maybe. 26 choose 0. How many ways are there to choose nothing of 26 items? Might surprise you a little bit, the answer. Let's plug it into the equation. So it's n factorial, that's 26 factorial, over 26 minus 0, because n minus r, so it's just 26 factorial, times r factorial, 0 factorial. Oh, well again, 0 factorial is just 1, so we're left with 26 factorial over 26 factorial, which is equal to 1. Yes, there's one way to choose nothing, right? Okay, so that's just equal 1. So basically, again, what the question becomes is just what's 26 choose 5. So that'd be 26 factorial over 26 minus 5 is 21 factorial, and also 5 factorial. If you do all that, you're going to get 65,780. Try it out, by the way. Try it on your calculator. Make sure you understand how to do that. How many different 5-card hands can be formed containing exactly 3 black cards? Exactly 3 black cards. Next day we'll look at ones where it's at least or at most to get a little bit more difficult. But today it's going to be exactly 3 black cards. So you can do the same thing. Black, red. How many black cards? 26. How many red cards? 26. How many black cards do you want to choose? Exactly 3. You want to make a 5-card hand, so how many red cards do you need to choose? 2. You need to do both of these things. So you're going to get this answer, you're going to get this answer, and since it's an AND question, you're going to multiply them together. If you do this, I'm just going to speed this up a little bit. This is going to be 2600. If you do this, you're going to get 325. And if you multiply those two things together, you get 845,000 hands that contain exactly 3 black cards. How many 5-person committees can be formed from a group of 6 women and 4 men under each of the following conditions? Okay, A, there are no conditions. In other words, you know, the 5-person committee can be made up of anything, all women, all men, 3 men and 2 women, whatever. It doesn't make a difference. So you're going to look at all the people in this case, all 10 people, and you're going to choose 5 of them. And if you do that, you're going to get your answer. So that's 10 factorial over 10 minus 5 is 5 factorial, and r is also 5 factorial, and that equals 252 if there's no conditions. Now, if there are conditions, do you think the number is going to be more or less? It's going to be less, right? So the first condition is there must be exactly 3 women. So I don't know, I think it's helpful to just consider both things. Women, men, right? There must be exactly 3 women. Well, how many women are there? There's 6 women. There are 4 men. We want there to be exactly 3 women. So 6 choose 3. And we need a 5-person committee. So how many men do you need to choose to make a 5-person committee? You got 3 women, you need 2 men. There you go. When you get these answers, since this is an and question, you want this many women and this many men, then you'll multiply them together. 6 choose 3 is equal to 20, and 4 choose 2 is equal to 6. And if you multiply those together, you get 120. All right, if there must be exactly 4 men. So again, women, men, there's 4 men and 6 women. You want exactly 4 men, so it's going to be 4 choose 4, and 6 choose, you already got 4 men. To get a committee of 5, you need 1 woman. 6 choose 1. Hopefully you'll start remembering stuff like this. If you got 6 people and you need to choose one of them, how many ways can you do that? 6. If you have 4 people and you need to choose 4 of them, and order doesn't matter, how many ways are there to do that? Just 1. Of course you can do this with your calculator if you want, but those are ones that you think you'll get used to calculating in your head. If there can be no men, so for men there's 4 of them, you want to choose 0 of them. Remember how many ways we said you can choose nothing of something? There's 1 way to choose nothing of something. And of the 6 women, if you want a committee of 5, you need to choose 5 women from it. If you think of it, what your 6 choose 5 is exactly the same as 6 choose 1 in some ways. Do you see why? Because in this one you're choosing 1 person to be in the committee, and this one you're picking 1 person to not be in the committee if you're picking 5 of 6 to be in the committee. Again, you could use your calculator, whatever method you want, but you're going to find it's 6, so you get the same answer. If there can be no women, so women, men, you got 6 women, but they can choose none of them. None of the women can be in there. How many ways are there to choose none? Just 1 way. And you've got 4 men, and you need to choose how many? You need to choose 5 of them. Okay, what do you think? I think we have a big problem. We have 4 men and we need to choose 5 of them. This is not possible. This would be a giant 0, or I suppose you could put a no solution. 1 times 0 is equal to 0. There's absolutely no way to have a committee with no women. And that should make sense to you, because if you need a 5-person committee, you can have no women in it, and there's only 4 men. This is not possible. Unless you're allowing monkeys or something in the committee, which would be definitely a worthwhile committee. Okay, see you next time for more combinations.